This is our last DMDN event of the year. Today we're going to talk about ethics and privacy for mobility data. And we have amazing speakers that I'm really excited to present here. The rules of the house is please save your questions till the end of the presentations, and remember that all our presentations will be recorded if you missed anything. Our first speaker is Denise McKenzie. She is chair of the Association of Geographic Information in the United Kingdom and co-author of the Locus Charter, a set of principles to guide the ethical and responsible use of location data. She is also a consultant in the international geospatial policy, strategy, and program management with a special in community building and public-private partnership, sustainability, and responsible use of location data. In a broader geospatial community, she is member of the Steering Committee of Women in Geospatial and advisory board member of the Locator-Based Marketing Association and PLAS. Previously, she has co-worked with as a co-director of the Benchmark Initiative and GeoBation, as a senior policy officer in the Victorian state government in Australia. And she is the head of outreach of the OGC, where she has led work such as the UNGGIM Geospatial Standard Guides. After her talk, we'll also have Esteban Moro. He's a researcher and data scientist and professor in the MIT Connection Science and Universidad Carlos III in Spain. He was previously a researcher at the University of Oxford. He has published extensively throughout his career, more than 80 articles, and he has led many projects funded by government agencies and private companies. Esteban has served as a jury in many data science and big data challenges. He's editor of several journals and has advised many PhD students. His work lies in the intersection of big data and computational social science, with special attention on human dynamics, collective intelligence, social networks, and urban mobility, in problems like viral marketing, disaster management, or economical segregation in cities. Apart from his academic career, he has worked closely with companies like Twitter, Telefonica, or BBVA in use of massive datasets and understand problems like how humans communicate, how political opinion spreads in social networks, or building alternative well-being indexes. And our last presentation, it's going to be from Alex Pompe. He is research manager at Meta in the team for Data for Good. His team builds privacy-protecting datasets to aid humanitarian response work in disaster and public health crisis. Prior to this, he worked on access to information and civil society development programs at an international NGO called IREX, first in Ukraine and then in NVIDIA, and then in Washington, D.C. Alex holds a BS in physics from the University of Illinois and a master from the University of Michigan. Thank you very much for being here, and without further ado, I would let the mic to Denise.
Excellent, and she'll just get her video on and share her screen.
Yes. No, I'm not sharing.
Always a good start. Always a good start. Whoops. Okay, right. Well, thanks for the introduction. Hopefully, can you see that all okay at the moment?
We cannot see your screen. We cannot see
Okay, then I need to do the share. Hang on. Share this again. Share that. Now you can hopefully see.
Yes.
Brilliant. Excellent. Okay, well, I won't do a big introduction then about myself because Andrea did a fantastic job there talking about all the different things that I'm involved in. But today, I guess I'm going to come to you to talk about the Locus Charter, but I guess some issues around that. So obviously we talked about ethics, but within ethics, one of the things that we looked at is obviously responsibility. Privacy is always something that comes up constantly as an issue when we talk about ethics, but I think one of the things that we learned in running the benchmark program was that ethical and responsible use of location data is so much bigger than just privacy. And I think you can kind of get bogged to some degree. So I'll talk about privacy a bit today, but it won't be the only aspect of ethics that I talk about. We will talk about trust, and within that transparency. And at the end of that, really one of the main things about the benchmark work that we did and ultimately the Locus Charter was looking at where we kind of find accountability in the work that we do and for the decisions and so forth that we make. So let me back up a little bit and have a look a bit about this sort of ethical topic of location data. I've worked in the geospatial field now for well over 20 years. And I think it's probably fair to say that up until about sort of 4 years ago, the idea of ethical use of location data was not really a topic that was highly discussed. We were seeing it talked about in the AI space, but it wasn't really for a lot of geospatial companies a hot topic, so to speak, for us to talk about. It was fairly fringe. And it wasn't until I went along to an insurance event that I was talking at, and we were discussing IT, and we were looking at the devices in our houses, and we were talking about sort of this idea that you can have these devices in your house and make the information about your location available to commercial organizations for, perhaps in the insurance situation, it might be for reduction of premium prices in there. And so within the room, we sort of said, well, where's your tolerance level? Are you happy to share with your insurance company every light switch that gets turned on? Which one, which of you did that? Is that fine? And we said to the room, who's comfortable with that? And we sort of, everyone put up their, about probably 80% of the room put up their hands and said, yeah, I'm happy to share my location information inside my house if it gives me cheaper premiums. We then said, are you still comfortable if they can differentiate between you and your children within that house? So from the data perspective, exactly the same sort of data, but suddenly it's a differentiator and I can tell that it's a child versus an adult. And immediately you watched in the room sort of this sort of ethical thing of, well, actually, no, I'm not comfortable if it's about children, even if it's the same type of data. And so it was at that point that I started to realize that, this intrusiveness of our location information and where we're sharing it and all of these different devices that were there. It crystallized for me really when we got into Cambridge Analytica and I started looking at sort of the impact of what happened in there. And sort of just, I think to some degree, how data was being used, how our information was being used and how it was being targeted to some degree to shape what we were doing and what we were deciding as well. But I will say that it was not until COVID-19 happened that we really started to question how location information, particularly personal tracking location information, was being used. And when all of these governments around the world started to try and track where the spread was happening, there was difference in how we were collecting data. Some governments were comfortable sharing the data, some governments were not comfortable sharing the data. The picture was completely different across the world in how we were understanding this. We also had governments building applications constantly to try and track what was going on with the best of intentions, but not necessarily always being transparent with what they were collecting, why they were collecting it, how it was going to be shared at the other end of it. And so I think location suddenly went from being a fringe ethical topic to being a really front page topic that was happening. Certainly for us in the UK, it was followed very quickly with a number of headlines like this, where the public were losing trust. Myself and my colleague Ben were in the middle of running the benchmark initiative at this point, and we started to really sort of, I guess, delve into what does this mean? Why is the public losing trust? Is the government actually doing something wrong? Or are they actually just failing to communicate and be transparent about what it is that they're doing? And, potentially, a little from column A and a little from column B on that one. But we also saw, geographers saying, well, I don't like what I'm seeing happening in the world. I don't like seeing how the organization I'm working for is using geography to represent what's happening. And I'm sure many people on this call would have remembered the Rebecca Jones situation that happened last year as well, where you've got a geographer that's basically trying to blow the whistle on practices that she feels are not appropriate in how we use geography and how we use location information. So for me, it was characterized really well, the issue, and that's that what we're trying to do now is all of these major problems that we have, whether they're pandemics, whether we're looking at the environment, it's all because we're trying to now express our world entirely in data. We're using data for everything. We're using it for our decision making. We're using it to do our planning. We are now talking constantly about digital twins. And data has permeated, particularly location and geographic data has permeated so many aspects of what it is we're doing in the world. But what we're finding increasingly is that that's bringing bias into the data that we're collecting. It's creating privacy issues. An area that I found really interesting to get into is looking also at that market power and data colonialism. So who has access to this location information? How is that being accessed? Who doesn't have access? Who's not represented within the geography that we're looking at as well? And whilst this datafication is bringing with it some great, insights and power for decision making, it's also bringing a huge amount of complexity. And because of that complexity, we're finding that organizations are not great necessarily at being transparent about what they're doing with the data, how they're collecting it, who they're sharing it with. And as a result of that complexity and that transparency issue, that's where the trust is being lost. And so when you start delving into sort of the issues around why the public are losing trust in government organizations and commercial organizations using location data, it's that there's no transparency, or the transparency is not communicated in such a way that the general public can understand it. So, I always love putting up this slide a bit and saying, so why does this matter to everybody on the call? As I said, I've worked in the geospatial profession now for 20 odd years, and we're all geographers. I think we have the most incredible skill to gather data, to interpret data, to analyze data about the world. And I think that with that power, comes a great responsibility to do that right. To do that well, and to do that in an ethical and responsible way. So the fact that this complexity is there means that we've got a greater responsibility now as geospatial practitioners to be transparent, to look carefully at the decisions that we're making about the data as well. So I've mentioned the benchmark initiative a little bit, so let me tell you a little bit about that. This was a joint initiative of the Ordnance Survey and a media network to, I guess, create a thought leadership program to start with. It started more than 2 years ago now. So it was on that sort of fringe before we had a pandemic side of things. And it was really about trying to surface, I guess, what the issues were around ethical use of location data. At that point, like I said, it was fringe. We really didn't know in depth what the great issues were. And as the program moved on, obviously we went into the pandemic, and actually it gave us real world, tangible, everyday issues that we suddenly began talking about. But as we had the dialogues and conversations, what we found was that there was an appetite to sort of get into more detail. And so we joined partners with Ethical Geo, which is part of the American Geographical Society, to run a series of workshops around the world. The workshops really tried to delve into looking at things like the unintended consequences of using location data, looking at the concept of harms and what we mean by harms, looking at what we as practitioners in this geospatial field, what are the values that we hold dear? What do we think are the qualities of good and responsible use within an organization or as an individual practitioner? And we looked at principles, and we did that all through a lens at the end of the day of what we called the location service life cycle. And it started in all the workshops, it started as the location data service. And someone actually said, no, it's a life cycle, because in any location service, you almost never have it just finished. The data ends up getting used somewhere else, or the service gets expanded, or things change. And so the location service lifecycle became a really useful tool to kind of go through each one of the phases and then think, well, okay, if I had to go back to the beginning now, but I was using an existing service, what would be the decisions now? And this was very much, I guess, a process of trying to work out, well, what are each of the questions? What are my ethical and responsible questions that I need to ask at each one of those different stages and phases? How could I record that transparently? How could I do that in a way that public would understand, would be able to easily consume and use? One of the best suggestions I heard was the creation of a transparency register to go alongside your services, which basically just very simply records kind of every single decision, who made it, when it was made, why it was made, kind of thing, and be able to have that as part of your project. But importantly, we talked a lot in there about how you communicate that. And there was I think one of the biggest takeaways that I got out of this series of workshops was that we have got so many talented, incredible practitioners in this space. And for the most part, they all want to do the right thing. But they consistently said to us, but there's no rule book for this. we've got no sort of set of guiding principles that we can work with alongside of this. And so out of that workshop, that was how we got the Locust Charter, which I guess was our simplified version of saying, well, how do we get to, I guess, a set of principles that everyone can be a foundation for us to say, well, is this what we all agree? Is this something we can get behind? Is this something, does this describe well for us how we want to operate as location data practitioners, and help us guide the use of what we're doing with our location information? So there are 10. I think it always looks quite simple when you put 10 like this up on the board. I can tell you trying to get to 10 and keep it simple is never easy in that sort of a space. And I'll just double check on time. I think if I've got a few more minutes left. Andrea, how many more minutes have I got?
Yes. I was going to write you have like 3 more minutes.
3 more minutes. Okay. Well, what I'm going to do is I'm going to skip over. I do have a video that I will share with everybody that kind of goes through each one of these 10, which is difficult to do in 3 minutes, which just means I'm going to skip that part there and just go into this part here. So the video will go into more depth to each one of those 10 principles and sort of why and what's behind them. What I would say about the charter is that we put this together really as a foundation. So what we want people to do is to take it, to use it, to use it to structure questions about the practice impacts of what you're doing, use it in roundtables, use it in training, but really feed back to the group of signatory organizations and tell us whether it worked or not. Tell us whether there were pieces that you felt were missing from it. Tell us if you think the wording doesn't work, particularly cultural context. Whilst we tried as hard as we could throughout those workshops around the world to include as many different cultures, backgrounds, diversity that we could, we're always conscious that there's going to be a certain level of bias in what we put together. So, we want to make sure that over time that gets fixed in what we're doing. So the website's there. You can go and have a look at the charter itself. I'll pop the link up in the chat after this. Just so you know the organizations that have been behind the creation of this too. So this was the foundation set of organizations that signed. You'll see some government in there. You'll see associations in there and some private industry supporting that. So these organizations are the ones that have sort of, I guess, agreed to be the signatory organizations to start with, to help guide, develop governance, and ultimately continue to develop the work around the Locust Charter. More recent additions that have signed, Albedo, who you would have seen in the news recently with their work with NOAA, Locust Charter, and obviously Ordnance Survey have also signed recently as well. I'm not going to go through this table. This is the most wordy table I have out of this whole presentation, but it was to say that, we are also not alone. Over those 2 years that we worked on the Locust Charter, we discovered multiple activities that were looking at different aspects of location data, some of it specific to remote sensing, some of it specific to IoT, some of it at national level, some of it at international level. But there's a huge amount of work currently going on. In the UK particularly, there's quite a lot of work now between the AGI, who I work with, and the Royal Geographical Society developing a national location data ethics forum at the moment. And literally an hour from now, the Geospatial Commission will be launching their report that's the outcome of their public dialogue on the ethical use of location data. And part of the reason that they've done that research as well is ultimately to feed into that broader dialogue about, do we need guidance? Do we need regulation? To what degree of regulation and policy do we need in these areas? So that the dialogue here in the UK has moved quite quickly in the conversations that we're having. And so that's my last slide, really. So be part of the community. I guess there's multiple ways. If you're an organization, know organizations that you think should be signatories, we'd be happy to talk to them. But also there is an email list that is on that website that you can join up with the community. And the community is really about knowledge sharing more than anything else at the moment. So we're just quite keen to hear and gather the information as to who else is working in this space. And that's probably the end of my presentation.
Thank you very much. If anyone has any doubts, I think this would be the best moment because I think Denise has to leave early.
No, that's all right.
That's all right. You will be till the end. Oh, okay, perfect.
Yeah.
So
All
then
good.
we could follow with Esteban's presentation.
All right. Can you hear me?
Yes.
Okay, and I think you can see my slides, okay?
Yes.
Okay, well, thank you very much. Thank you, Andrea, for having me today. This is a great venue, and I hope I can convince you today about the initiative that we have been running for the last couple of years at MIT, which is called Trust Data Mobility. Well, my name is Esteban Moro, and Andrea, thank you very much for your nice introduction. And I said I'm a professor here at MIT and also Universidad Carlos III in Madrid. So one of the things that we have been working for quite some time already, I've been working with these big data sets from location for the last 15 years, is that there has been an enormous amount of people working on this data from many angles. And I just want to bring you one initiative that we have been running for the last probably more than 10 years, which is the NetMod conferences, in which we basically gather people that are working in industry, but also people that are working from what we call today computational social science, in the use of this location data for many different purposes to understand societies, economies, mobility, cities, and crowds. We've been working with this location data for quite some time already, and pretty much, I mean, this is the disaster network at World Bank. So most of you probably know already, we organized almost 10 years ago, the first D4D challenge, in which a telco operator was sharing data under a privacy preserving framework to try to use this data to analyze questions about, for example, energy, about economies, about mobility, etc. So, and we also have in part, for example, for the D4R, which is data from refugees, how we can use the location data to understand refugee movements in Turkey and in other emergencies. The other thing that I can, in order to summarize this response is that we have been helping the community, but also the providers, the telco, and the companies which are providing this data, to try to see how we can create a sustainable way in which these databases are used, not only for their purposes, but also for the society, for the purposes of understanding our society and understanding problems like, for example, mobility, refugees, and you will see in a minute, segregation, and also recently the COVID. So this is the initiative that we have in MIT. The initiative is that how we can actually build a sustainable, privacy-preserving, trusted way of using this mobility data in many different problems. This is actually part of what is called the MIT Mobility Initiative, and basically our group is focused on use of this data for what we call computational social science, for problems that have to do with our urban, with our cities, with our society, but also with our health, for example, recently in the COVID times. So we have many projects. I'm going to talk today only about a set of them, but we have, for example, projects about food insecurity. We have problems about the future of work, but equitable transportation, mobility, community resilience, and offline versus offline segregation, etc. And most of these projects are actually done using location data that comes from many sources, and as I will let you know in a minute. And probably I don't have to convince you today that we have many problems in our cities today, and most of these problems can be understood using mobility data. For example, the new forms of mobility, the new forms of transportation can be approached using the mobility data. Epidemics, I mean, the previous speaker was talking about the use of mobility data, location data, to understand the evolution of epidemics in our cities. But other problems, for example, like environmental impact, sustainability, labor markets, new forms of governance, all of them have to can be understood also using location data. And specifically, our philosophy in the group is that we can understand the city much better if we understand the behavior of the people living in the cities. And one way to approach or one way to understand the behavior of people is to use location data. We in our group, we have been working closely with all these location databases for more than 20 years already. So we get many data. that comes not only from the social demographic data, like for example, the census, but also surveys. We do a lot of surveys in our group, but we also use what we call activity data that comes from calls, from the use of applications, credit card transactions, consumption, transportation, location, GPS. We use all these data sources that can help us understand the behavior of people in the cities. We are lucky that we have many very big partners in this endeavor. And for example, we are using location data that comes from mobile phone applications, which I think is what the previous speakers were referring to, the security data. We also use credit card transactions that come from BBVA or MasterCard. And we also use data that comes from mobile phone calls or the use of, let's say, data from telco operators. Like, for example, we do with the Grand Data and other operators, for example, Orange in France. The key idea of this data is that this data is multidimensional. So you want to understand what is happening in the city. You want to actually extract the information that is coming from this data. But obviously, there's a problem because this data, especially the activity data, it's very individual. It has the most of this, the value of this data comes at the individual level. So it has a lot of problems in terms of privacy. So the philosophy that we have in our group is that from this data, we can take two routes. The first one is the prediction route, in which we basically use this high dimensional complex data, and we run these high dimensional predictors, typically deep learning and machine learning models that you might think about, and we can do predictions about, for example, how many people are going to go from point A to point B today, how many people are going to take the bus, what is going to happen, for example, if there is a disaster in an area, and there's a person in our group, Taka, that has been working on how people chose the evacuation routes using this data. And the other route that we take in our group, which is more the one that I want to talk about today, is the low dimensional representation of this data, in the sense that we can extract from this data the basic ingredients of the human behavior that are happening in the city, and how these basic ingredients, which of these basic ingredients are more informative to explain problems like, for example, mobility, inequality, epidemics, or economic recovery. These low-dimensional representations are very similar to what people think about the lifestyles. I mean, to try to determine how to try to investigate what are the basic ingredients of human behavior that are encoded or that are present in those databases. But because today we are going to talk about privacy, let me just mention 3 projects that we are going to do in our group. Well, I mean, the first one has been running for a long time. That has to do with how we can we build a trustworthy and privacy-preserving way of accessing this data. The first one is the OPAL. OPAL is an initiative in which we are part of. You can go and see the OPAL project, in which this is basically a multi-distributed, multi-computational distributed algorithm to access the data without actually moving the data. So basically, the OPAL project is making data available for inspection, in which we move the algorithm to the data instead of moving the data around. So we don't have to access the data. We just send the algorithm to the data. We do these multi-party computations, and then we extract the information that we want from the data without actually accessing the data. Most of our projects that I'm going to talk today are running this framework, in which we don't have to actually access the data. The data is still in companies' premises, but still we can actually extract information from the data. We can run our algorithms. The second part is pretty much, we believe that the next step in using this data is to build a census. And census, something similar to what the census has done. Typically, the census, the way we understand the census is that the census is a collection of questions that are asked to people about their behavior. So we believe that we can do the same thing to this data. We can build up what we call a mobility-rich census. We can ask specific questions to this data, and we can build a census of these behaviors that are encoded into the data, rather than using the data of the privacy data. With that, you can read about it in the project of inequality. And with that, what we can do is we can extract low-dimensional privacy-preserving representations of the main behaviors in the city without reproducing or accessing the individual data. And obviously, if we understand what are the main ingredients, the main behaviors that are encoded into the mobility data, we can actually go beyond this census, and we can start generating our own data sets. And this is the last part that I want to talk about, is that we are using deep neural network methods to generate synthetic mobility traces that retain the aggregate, but also the individual properties of the data, and can be used for applications like, for example, the COVID or any other public good settings. And you can read about it in this webpage. So let me talk to you a little bit about what is the kind of things that we do with this data. The first project that I want to talk to you is about inequality. We have been working in this project for 5 years. We started this project actually in 2016 when we got access to this location data. And the key idea about this is that the location data can not only help us define better or predicting better things, is that actually the location data can actually allow us to ask different questions and approach different problems from a different perspective. And that's what we wanted to do with the Inequality project. The Inequality project that you can find in inequality.media.mit.edu, the Atlas of Inequality, is a project in which we map the inequality, the economic inequality of the different places that we have in our cities. So this is, for example, New York. This is the Atlas, where you can see here each point is a place, and they are colored according to the economic profile of the people that visit those places. The key idea here is that the segregation, I mean, the fact that we live apart from each other in the cities, is happening at the level of places. Places which are separated 10 meters can be completely different segregated. And that's one of the things that we found. And we try to investigate what are the reasons why some places are segregated, why some places are not segregated, and what is the dynamics of those places and what is happening around those places. And obviously, the key question here is to try to understand how much this is impacting the everyday experience segregation that people have in our cities, and how this translates into the lack of opportunities or the exposure to opportunities of the different groups in the cities. One of the things that we've been recently working on is to try to extend this Atlas of Inequality using this location data to understand the impact of policies in the cities. And we are, for example, now mapping every city in the United States, every street in every city in the United States, and try to understand what is the diversity of people that are visiting the cities, and how different streets are changing the diversity by year, and what are the interventions which are changing the diversity of the people that visit those streets. And we are using many different location data, from data that comes from companies like Cubic to other location data that is extracted from, for example, Google Street View to quantify the interventions that we see in the city. The other problem that we have been working is obviously epidemics. The location data can tell not only the location data that comes from Bluetooth, like the previous speaker was talking about, that can inform you about the contacts, but also the location data can inform you about, for example, how effective are the stay-at-home orders, what is the community transmission that is happening in the cities. And this is how we be using location data to understand how people are moving in the city, what places they are visiting, and how this information can tell us about where spreading events are happening, which are the places which are more susceptible to host super spreading events, and how different cities, because people in different cities have different behavior, how different cities can react differently by implementing different social distances, which are more targeted to where specifically where things happening. So just bring you one results that we have in our paper is the different routes, the different paths that the epidemic have during the first wave in New York and Seattle. While, for example, in Seattle, in New York, most of the super spreading events from our simulations were detected in arts and entertainment. In Seattle, none of them were actually happening in the first wave in arts and entertainment, and the opposite happened for groceries. It's actually what we see in the methods. So that's the good thing about this is that we can actually go beyond those models, which are basically just counting the number of events, and try to incorporate the human behavior in those models, and try to see how human behavior modifies and sets the path for the epidemic spreading in different cities. And obviously, you can think about also the possibility to use this information to implement much more efficient and more targeted policies. And the location data can also be used for many other purposes. For example, this is a study that we recently published in Nature Communications, in which we found, using the location data, the physical activity. The location data can be also used to estimate the walking behavior of people. And we did an estimation of the walking behavior in the different cities during the pandemic. And what we found is that, yes, people walk much more during the pandemic, but only a specific group of people. Only high-income people actually got out and walk more, and most of the low-income people and most of the people living in vulnerable areas, they actually didn't walk out more, because most of the walking activity by these low-income people come from what we call utilitarian, going to the workplaces, going to the restaurant, going to the shops, etc. And the fact that everything was closed down implied or ended up in having less physical activity for low-income people, which is what we call the second pandemic, that people that from low-income communities were impacted differently by this physical activity. The other project that I was talking about is what we call the mobility rich census. The idea is that this mobility data is huge, but it's very complex. It has many properties. But one of the key questions is, how much information does this mobility have? How much information does it have? How much different behaviors that we have in the city? So this is what we have been doing in the last couple of years, to use this location-based services data and use low-dimensional representations of this data using deep learning to try to understand how much information do we have in this location data. And the key idea is that we can actually use these low-dimensional representations, which we call lifestyle, to build this mobility-rich census, which encodes most of the information that is in the mobility data, but in a low-dimensional representation, which help us the interpretability, but also the privacy preserving. The key idea is that each of us the mobility of each of us can be decomposed into, let's say, the DNA of lifestyles. So each of us, for example, has a mobility that is composed of behavior we call out and around, coffee shop, office life, shopping weekends, shopping during the week, etc. And we can actually reconstruct the mobility of each of the individuals by using these different weights that we have in the different lifestyles. We found, like typically in the United States, there are only 12 latent mobility behaviors, and the mobility of each of us is basically the composition of these mobility behaviors. They go from college to factory, education, socializing, shopping weekends, etc. So it's actually astonishing to see that the mobility of millions of people in the main urban areas in the United States can be decomposed into these 12 low-dimensional representations of the behavior. And what we have found actually is that the latent mobility behaviors that we predict can actually be can complement the census data, to the point that actually they are much more predictive of future behavior than the census. For example, the distance traveled, the commuting time, or the walking activity can be very well described by the different latent behaviors that we identify in the mobility data. And this is what we are doing now. With the next thing that we are going to do is we publish this data. We are going to publish data by census block group. We are going to publish how many out and around behaviors are, how many shopping weekends behavior are, how many office behaviors are, with the purposes of that this data can complement the census, and can be used to investigate future behaviors or future, let's say, problems, without actually having to access this individual mobility data. And the last thing that the next thing is that if we understand this data, we can actually have this low-dimensional representation. The next thing is that if we can actually get away a little bit from the individual data and start building synthetic data that can represent this mobility in the cities without actually being the individual data, the real individual data. And this is what we are doing. This is a paper that has been recently published in the CAC 22. And the idea is very simple, is to encode all these user models or recurrent neural networks or GANs. I mean, you can use whatever fancy techniques that you are interested in and using the trajectories of people as input. We encode all this information into one of these deep learning models, and then we use adversarial methods to actually reconstruct synthetic trajectories. And the key idea here is obviously that you need to have an objective function. The objective function is that the synthetic trajectories that are reconstructed retain aggregated patterns. So basically the flows of people going from one place to another are reconstructed, but also that they describe the main mobility traces. For example, we need synthetic trajectories that really account for the usual behavior. Like, for example, behavior of how people shop, how people work, how people move around. So we need synthetic data that reconstruct, for example, that people go to the office and then they go to them for lunch, and then they go pick up the kids at school and they go home. Okay, so this is the basic thing that we are doing now. So I would like to thank you, and we are working on many of the projects and didn't have today to talk, but I will leave it here. And I'm happy to answer your questions. Thank you.
Thank you very much, Esteban. It was really interesting. I hope you have a lot of questions for the end of the session. And now I would give the screen to Alex.
Hi, everybody. It's great to be here. Just interrupt if you're having trouble seeing my screen, but let's just dive in. The team I work on at Meta, formerly Facebook, is called Data for Good. We build around 25 different data sets that are basically externally shared, derived from either Facebook user data or fully public data sources that we believe have the necessary ethical privacy protections so that they can be shared externally, primarily to the humanitarian, NGO, and academic research community. And then they can use this data to save lives. You can find out information around all 25 of those data sets at the URL shown here, and I'll drop it in the chat. But let's dive into, I think today I'll just have time to cover the first, but there's kind of three main areas that I'm most excited about in our work over the next year. But the first question around privacy protection is how we might construct weights to ensure that our sample population is representative of the overall population, to make sure that we're not missing, especially in the context of crisis response, the most vulnerable groups who are experiencing the effects most pointedly of natural disaster and epidemic crises. And if there's time, we might spend a little bit on differential privacy or federated analytics, but maybe another session. So the overall problem statement that we're trying to solve here when we're building a privacy protective data set around a crisis event, here's a very simple version of the world. We have a population of smiley faces, and some of those, the ones in blue, are Facebook users. And some of those Facebook users, the ones with the antennas on their heads, have opted in to sharing a particular type of location data with us. This is called location history in the context of the map that I'll be describing to you. So we know that when a crisis event happens, that some of these people might need to leave their homes, they might be displaced. And so that's what we're trying to measure. We know that not everyone is being displaced, but we also know that not everyone is sharing that full location history data with us. So how do we bring those two challenges together and provide useful but also ethically shared data to those responding to the crisis so that they can save lives? We do so in two ways. Presently, we're just making available reports with noise added of the location history user data's displaced over time and space. And what we will be doing starting in 2022 is creating a version of this data set which is weighted to the overall population. So instead of reporting just a noisy count of the location history users that have been displaced by the crisis event, we'll instead report our estimates of the overall population that we believe has been displaced by looking at that sample. The way that we're doing this is in two stages. We're not simply providing the data set with a bunch of covariates or variables because this would collapse our privacy protection. If we began producing the data set with age, gender, frequency of connection, device information, if we made those variables available publicly, privacy would quickly collapse. Any one or two of those over the aggregations of time and space are likely to be uniquely identifiable within even an aggregated location history data set. So that means we can perform some of these weightings on our side, where Facebook is the only one who has this information, is performing the weights, but then we need to provide transparency on our methods so that people will trust them. So we have to provide transparency while at the same time not breaking down the privacy. So all of those user level data that we will use in our inverse probability weighting, the main variables are listed here. Very typical, the age, the gender of the Facebook user as reported in their profile. We also can look at things like their frequency of connection and correct for biases there. And then also like the general family of their device, how much RAM it has, things like that come as a result of any mobile app being installed on a mobile phone. The second level of weighting that we will produce is based on tile level data sets. All of these are publicly available, so you would not only be able to reproduce and build upon this, but also audit our methodology here, and we welcome this feedback. We're going to weight according to population density using our own high resolution settlement layer. We'll also score each of the tiles according to our estimates of poverty and wealth distribution, which is the relative wealth index we call. And lastly, the density of streets and infrastructure available in OpenStreetMaps with our own estimates of the streets that are missing that we've detected in satellite imagery. And the method is not anything super the inputs to the data are kind of the novel thing. The method applied to produce the weighting and inverse probability weighting isn't that exotic, but like I said, it's in 2 stages. So here's a visualization of what that is. We have our location history users, and we can compare those user level, age, gender, frequency of connection, and device to the other Facebook users that are present in the same tile, and that is the second stage. And then the first stage is we're weighting the similarity of that tile to the other tiles in the data set. So from a recent crisis event, this is the most pointed and most important, I think, aspect of the correction taking place in the weighting. We want to be sure in the context of a crisis response that displacement caused by like this volcanic eruption in St. Vincent, that we're capturing across both genders representatively, and especially across different socioeconomic status. So here we've taken the quantiles of our relative wealth index estimates of poverty and wealth distribution, and we've compared the unweighted location history sample that's produced today to our weighted corrections across ranges. But you can see that even the source data, the unweighted, had total gaps in the medium high category. So there's no correction to be made there, but just to give you a sense, even for something with the reach as such as Facebook, there are gaps in these data sets that might not be recoverable. So it's very important that we're able to publish and share insight on this methodology so that we can be transparent around gaps in data and not portray data sets as silver bullets to a crisis response. And to summarize, so for this particular displacement event, we produce this data anytime there's a safety check on the Facebook platform. It's available to vetted NGO and academic researchers under a data license agreement. I'll share the link to that in the next slide. Our reweighted estimates of the overall population that were displaced was around 19,255 individuals. And we produce this estimate each day. We can update the number of displaced people daily and the number that are returned, and of those that are displaced, where they are displaced to. Post-crisis, several weeks after the crisis, IDMC, who has been our partner in developing this methodology, used other more traditional sources of data and estimated the overall displacement from this eruption to be around 22,000 people. And in the news media, we saw, again, sort of these roughly 20,000 people estimates for the event. So we feel like we're making strong progress. We're getting closer to alignment amongst 3 different methods to estimate the total number of people who are displaced. all have their pros and cons, and hopefully, you know, providing greater transparency into those pros and cons and the gaps that might be inherent to any method allows us collectively to arrive at a more holistic response, especially to understand who those of the most vulnerable population might be being missed whenever we're reporting. So as I mentioned, here's the links to the various data sets and our program. I'll also drop those in chat, but really welcome your questions. And thanks so much for letting me share about our work.
Thank you so much for your presentation, Alex. So now we could start with the questions, if anyone had for our speakers.
I'm one of the speakers. Can I ask a question?
Yeah, sure.
Yeah, I have a question for Alex. Thank you, Alex, for the talk. I was going to ask you, which are the dimensions typically in which you reweight the data? Like, I mean, I've seen, for example, income, but there are other dimensions like education, gender. I mean, are there dimensions that you're considering?
Yeah, we don't have education levels in our weighting schema presently. It's basically that age and gender is the simplest and tried and true. And then we're trying to get some sort of, the first place where we're trying to correct for bias is sort of in this socioeconomic status. And the device family, the frequency of connections, and then the relative wealth index provides some directional measure across those for each of the two stages. So the frequency of connection and the device family can be attained at a user level, and the correction made in that stage one. And then the overall like raster comparison at a tile level of relative wealth index is what we use at the stage two. So it is still, I'd say, our first step into this area, and there's plenty more covariates that we might explore. The main limitation in these things is global availability, since we're trying to make sure that our methodology is reproducible for all of the crisis events. But happy to discuss further. We're just getting started here, I'd say.
Thank you.
I have a question for Esteban.
Go for it.
Yes, thanks. So I'm curious about the synthetic data generation. So I wonder if like you can have like one algorithm, like one training data set for every country and then fine tune, or do you have to train everything with the data specific for each country, or is each specific socioeconomic groups? Or like, how do you segregate those type of different behaviors with that?
Yeah, I mean, we are just on the piloting this project. So we are basically running this in the main urban areas in the United States. But as I was telling you, the model for mobility in New York is different from the mobility in Seattle. There are many commonalities, but there are many nuances which are important. For example, Seattle is much more suburban than in downtown Manhattan. So we are running this by city right now. We are just piloting this project in 3 cities, and yeah, so that's that. But ideally, I mean, at the end of the project, the idea will be to have a model that can reproduce more or less the mobility of the main urban areas, but in the United States. But definitely, I mean, there's chance to extrapolate this to other cities and hopefully to Mexico, right, Oni?
Thank you very much. Great talk, like everyone.
Yes, Phil?
Yeah, good morning. I have a question for Denise. In regards to data equality and equity, what different strategies have you guys been describing or discussing or developing to take into account the differences in the diverse communities that want to use and have access to data, but may not have the same resources? I'm curious if you've been working in that area of communicating the data, taking into account those diverse communities.
So not in any great level of detail, Phil, I guess, down at that level. Certainly that came up as part of the discussions in the workshops, is that sort of inequity of access to the data. And so when you look through the principles, some of that's trying to sort of say we need to take that into account, looking at representation, looking at, vulnerability, looking at who has access. So that's a sort of, I guess, data colonialism element of things that you need to take into consideration. I know that globally there are a number of organizations that are sort of looking into that aspect, certainly from University of Southampton and the World POP program. There's some aspects there. There is also the NGO that I'm on the advisory board, Place, is being built, I said, essentially as a data trust that's about trying to improve that accessibility, particularly to governments that may not have access to the data that they may require. So if you're interested, by all means, go and have a look at Place and sort of look at their new governance structure and the reasons behind why they're creating the data trust they are there to try and improve those issues. Hopefully that helps.
No, it does. Thank you. And I really appreciate your whole conversation of the life cycle of data and keeping all those different stages in mind as you think about equality and equities. Thank you very much.
Yeah, that one was a real learning curve for me in looking at was illustrated so well with a platform that was built initially for looking at flooding within a city. And then someone said, oh, can we use the same platform and now look at forest fires instead? And they just sort of said, yeah, sure. It's sort of, and a whole raft of unintended consequences kind of came out of that they hadn't worked through in looking at changing what they were doing into a different sort of platform and a different use case. So yeah, the life cycle was a really good way of looking at it.
Perfect. Thank you so much for your presentations, Joel. I think we run out of time, but feel free to write me and then I can reset the questions to our speakers. Thank you so much to the ones that have been following the series all half of this year. Have great holidays and hope to see you next year with a new series of the MDN. Have a great day.
Thanks, Andrea.
Thank you. Thank you very much.
Thanks, everyone.